So we're going to follow the same steps every time we do this. Pull everything to the left-hand side so that the zero's on the right. Find your critical values, refactor, set them equal to 0, factor. We don't change the problem by setting it equal to 0. We're just finding the roots of your equation. We separate your number line according to your roots, your zeros. We test, and then we say, did we want a positive? Did we want a negative? Remember, when you're looking for your value of your function, it's the y value that's returned. So if you say, I want this whole mess greater than or equal to 0, it means this is where my y was. I want my y to be all my positive numbers. If I say less than 0, then I want my y to be negative. That's the only thing we have to look for. Is it positive? Is it negative? Because an inequality has more than one solution. So we have to take a different approach to this. Okay? And I have to say, this one is the one that confuses kids the most. They're okay when we do it, but then when we mix it into a regular problem, then they have a little trouble with it. This was on your Regents as well. So let's start here. We're going to pull everything to one side, pull everything to the left. And you can see that we have to because we have descending x's. So subtract 12 and get the 0 on the right-hand side. Yes. So, get everything to the side. Now, we're going to factor. We're going to factor and find the roots of your equation. Yeah, it's greater than 1, so we're going to use a times c. 2 times negative 12. What is 2 times negative 12? Good. What are factors of negative 24 that add up to positive 5? See how easy this is? This works every time. X. Now, replace this with this. So, 2x squared plus 8x minus 3x minus 12. And group. What can we take out of the first group?
Turns into an equal.
It turns into an equal just so we can find your critical values. We need to find the zeros of this. So we set it equal to 0 and we find the zeros. Good point, because it's still an inequality. Our original problem is your inequality, but we have to find your cutoff points, your zeros. So what do the first two terms have in common?
2x.
2x. What's left? Good. Now, out of this mess, I need to get an x plus 4. What can I take out? Good. See how easy this is? This is the common factor. And what's left? 2x minus 3. Set these equal to 0. These are your critical numbers. So we're going to set up a number line. Negative 4. All I need is the critical numbers on there, but I need them just to be in the right order. And 3 halves. Now, this is how we segment your number line. Again, we look to see what this inequality is. You need to know, is it an open circle? Is it a closed circle? Open or closed? Open because? Not equal to. Good. So put an open. Anything greater than 0, think about your number line. Is it going to be a positive number or a negative number? Positive. So we want to know where the positives are. We have two ways we can do this. The right way. We can take this, put this into your y equals. When it graphs, you're going to see the roots, and you're going to see a parabola that goes like this. This is your x-axis somewhere, your y-axis. This is your x-axis right here. This is your y-axis somewhere. All we care about is your x-axis. So that's what your parabola is going to look like when we graph it. So we know that this is a parabola opening up because x coefficient of x is positive. Now we want to know where the y's are negative. So we technically can pull up your calculator, put this in your y equals, and test a number over here. When x is negative 5, you look in your table. All you need to know is y positive or is y negative. So we look at your table, and y is positive. So we put a plus sign up here. And see it here from your graph? Isn't this where y is above the line? So y is positive. So sometimes if you can place your parabola here, it's easier just to look at your parabola. We pick a number from here to here. So I pick x is equal to 0. I look in my calculator, and I see y is negative. You checking me, Paul? You see y is negative? Okay, so I put a negative down here. Keep your positives above the line, keep your negatives below the line. It should look like it does on your graph. And I test one out here. I say x is 3. And I notice y is positive. So I go back to my original problem. And I want the positives. So I want this section. And I want this section. So my solution is negative infinity to negative 4, or 3 halves to infinity. This is my solution. You can absolutely put this in your y equal and pull up your table. All you're looking for when you pick a value to the left, to the middle, to the right, is if y is negative or positive. And put it on your chart. And then go back to your problem and say, oh, only positives, I want the or statement. So we go through the right steps. We pull everything to the left side. We set this equal to 0 to find our critical values. Your critical values are your zeros. If you take a look at this, that's where it crosses the x-axis. Those are your roots, your solutions, your zeros. We test each section. You can put it in your calculator, or you can say, well, this is a parabola going through these roots, and it's opening up because a is positive. And you section these off like this. Right at your critical values, you get 3 sections. Section 1, Section 2, Section 3. Do you remember doing this in Algebra 2? A little bit? You probably did the testing. They probably didn't throw the parabola in there. We're real big on graphs in pre-calc. We're real big on graphs, explaining what the graphs tell us. We use the graphs to get our information. So this is a real nice way to actually place your quadratic on the number line. It is part of your axis anyway. It's like your x-axis. Let's try another one. Let's try another one. This one's a little tougher because it's a cubing function. So this one we might have to pull up the calculator and graph this. Is everything to one side, to the left side? Yeah. Good. So we're going to factor it. We're going to factor it. That 2 is just a number 2. We're going to factor it and find our critical values. Everything is to the left-hand side. We need to find your critical values, your zeros. So I have 2 terms. What's my greatest common factor? 4x squared. What's left? Set this equal to 0. We want to find your zeros. So x is equal to 0 and x is equal to 3. Should it be opened or closed? Closed, because the equal sign. Now, what we're going to do is graph this out, because this is a cubic function. A cubic function is the one that goes up from either end, either the positive or the negative. It's a harder to see. Your cubing function usually goes like this. So we're going to graph this guy. I'm going to pull my calculator up. Okay, so we're going to come here, and we're going to put that equation in your y equals the original equation. We're going to just do a zoom 6 because I think this was a trig graph. Now, here's your zeros right here. See them? At the 0 and at the 3. There's your zeros. So we're going to take your number line and we're going to shrink this down. Here's your 0. Here's your 3. These are your test intervals. If you visualize this like this, it's easier. You can see where your negatives are. You can see where your positives are. So let's test. We pick a value to the left of 0. So we pick x is -1. So go to your table. I guess I can't go to my table. Okay. So let's go to the -1. So when x is -1, all we need is the positive or negative of this. Y is negative. And we can see the y negative. Now, you've got a root that bounces off the 0. Then from here to here, we're going to pick x is equal to 1. X is equal to 1, that's also negative. Then we'll go to x is 4. Pick one value over here. That y is positive. So your graph should look like this. Right? Your original problem said greater than or equal to. So I want anything positive, and I want anything also 0. This right here is the positive. This is the positive root right here. But this has one more little problem. We said greater than or equal to 0. This is greater than 0. There's my plus. But this little point right here, that's equal to 0. So your solution says 0 or 3 to infinity. Can everybody see that written over this mess here? We tested your number line, and we looked for the positive. It's a cubic function, so it doesn't look like a parabola. You can superimpose it on your number line, or you can just use your calculator and go to the left, to the right, to the middle, whichever way you need to go. But the one thing that put us up here was the equal sign. It needed also to be equal to 0. Now, if it didn't have an equal sign, we wouldn't count that 0, because that wouldn't make it true. And at any time, you can test those values. Test them in your calculator and make sure they work. Good? Okay? Shrink this down. All right. So we're good with this? Okay. All right. So your homework is the worksheet. One. When you move the 25 over, you're going to have a hard time finding your critical values unless you FOIL this guy, order of operations, and then collect your like terms and factor again. So plus 2x plus 2x plus 4x plus 4. And now you can combine these. So what factors of 21, negative 21, give me a positive 4? 7 and 3. Good. Set this equal to 0. These are your critical values. set them equal to 0. A lot of times there's no shortcuts. You have to follow order of operations. You have to follow all your sound practices that you've been learning over the years. Set your critical values up. Is it going to be an open circle or a closed circle? Excuse me. An open circle. Down. This is a parabola. Does it open up or down? It opens up. Those are your zeros. Those are your roots. Those are your solutions. Your parabola looks like this. Can you do this off the parabola without testing? Right? You can do it either way. This to the left, this is where your value is. It's positive. In the middle, this is where your value is. It's negative. To the right, your value is positive. And you want which ones? The less than. You want anything that sits lower, less than, lower, below the line. I want this right in here. So I got -7 to +3. At any point, test them, make sure it works. Pick any value in there. Pick the 0, plug the 0 in. 0 plus 2. 2 squared will give me 4. Is 4 less than 25? Yes. Just do a mental check. Nothing formal. We don't do formal checks. Just a mental check so that you know it's working. Good? Okay, so you have the rest.